So welcome back to the channel, guys, and this is going to be a great one for everybody to watch. Make sure you stay tuned for the full entire video. So I'm normally renowned for building 2Js. I've built many 2Js over the years, but we're going to move on with the times, and today we're going to be bringing you the video that everybody wants to see is the GR Yaris 3-cylinder. We've got a brand new block. We're going to take it apart, do all the measurements, find where the weak points are, and then we're going to build this engine for Christian, and it's going to be an absolute monster. Let's see if we can do 600 horsepower reliable with this 3-cylinder. So we were up there on the cylinder pressures, close to 200 horsepower per cylinder. Anyway, guys, stay tuned.
So this is the first look at the short block, guys. Let me know what you think.
So I'm looking at this 3-cylinder. I've not looked at one of these before. Luckily, it's a brand new block. So first inspection, it's got a fully open deck. It's not ideal for power. It does mean that the cylinders can shift a little bit, especially around the head gasket clamping force. I'm surprised they didn't go for a semi-closed deck block or alternatively a fully closed deck block. So our first weak point may be the open deck. However, when I'm looking at the bores, the wall thickness is pretty chunky, actually way more chunky than a 2J. So I can see why they can hold a lot of power. What else can I see with this engine? So before I strip it, I'm going to take some measurements, but what I can see is that it looks pretty chunky. I can see the pistons are nicely machined. They've got some angles on the pistons to help some turbulence inside the cylinder because the engine will be direct injection. So they've got some different kind of angles there to create some turbulence inside the cylinder because we're not injecting the fuel through the port to start off with for our economy kind of driving. What else can I see with it? It looks great. I mean, it looks basically like a half of an R35 engine, and I've built a few of them and there's no real difference, but it does look great, and I'm happy that this is going to hold a decent amount of power. But we're just going to make sure that we take this engine apart and get all the measurements that we need. The main thing that we are going to need to do, we're going to put pistons and rods in this engine, but we need to make sure we get the balance factor right. Now, I have heard some stories that the cranks aren't exactly dead center on the engine. So I'm going to check that as well, see what the offset is, and then we're going to work out the balance factor as we go with this build. So looking at the cylinder wall thickness, it's pretty chunky. I mean, we've got 11.8 mil on that cylinder wall. Put it down there. A little bit thinner there. Nice to have an ultrasonic tester to see what they are. 12 mil. 12 mil. There's a big chamfer on the top of the bores. That's going to help when we install the pistons. Yeah, I would say an average of about 12 mil cylinder wall thickness. So that's pretty chunky. That's going to hold a lot of pressure before that deforms. So now I've flipped the block over, I'm going to look and inspect the cradle. So looking at the engine, it's very well supported throughout the tunnel of the engine. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18 bolts actually holding the cradle to the block. So that's going to give the engine a lot of rigidity whilst it's running. Now, obviously it is a 3-cylinder, so naturally it's going to be out of balance. So we need to make sure that we get the balance factor right so the engine doesn't rumble, which will give us a longer life. So yeah, I'm looking through it. I can see that there's a mixture of die-cast aluminium with some steel main caps, which is cast into the cradle itself and then machined. Lots of O-rings and O-ring grooves, which is great for sealing, no gaskets. But yeah, it looks really strong. For a 3-cylinder, it does look very, very strong. So now I've inspected the block. I'm happy with the structure of the block. It's chunky in areas. Yeah, I'm happy to start taking this apart, and that's what we're going to do next. I'll put a time lapse up and We'll pull the crank rods, pistons out of it, and then we'll start taking some measurements of the thickness of the ring lands, the thickness of the wrist pins. We'll see what kind of bearings it got in it. We'll check the journal sizes. We'll check the bore sizes of all the rods. We'll check the bore clearance between piston and cylinder wall because it's a brand new engine. That's going to be like the perfect tolerance, so we can see what they were built to out of factory. And the other very impressive thing about this engine is it's got 3 piston squirters per cylinder. I mean, I've not seen that before. 1, yes, 2 occasionally, but I've never seen 3. So they're doing a really good job of making sure the crown of the piston stays super cool. So that's why they can run a leaner air fuel ratio and still keep the power there without promoting knock and debt.
Yeah guys, so I'm just marking all the rods now, just making sure that they stay together in the same position. Using a torque wrench to undo it. I'm just curious to see what they undo at, seeing what torque they undo at. There you go, there's number 1 rod bolt, number 2 rod bolt, and the cap. Just checking the bearings, very much similar to an ACL bearing. I use a plastic instrument here to pop the rod and piston out. Just making sure I don't damage anything as I'm doing it. Having a look at the piston crowns as well. There's the next one. This is real time, so there I go. Seeing what the torque undoes that. Number 2 cap coming off now, then on to number 3. Let's get these rods and pistons out of this engine.
So the rods and pistons are now out this block, and they are quite strange already. I can see they've got a special coating over the bearing. There's also no tangs on the bearing, so the bearings will be able to go either way round. From a lot of information that I've read and engines that I've built over the years, tangs aren't necessary. The tangs are only there to make sure the bearing is central within the connecting rod or the main journal. Without any tangs, it means you have to manually put the bearing in, centralize it in the rod, and then squeeze it in, and you rely on the clamping force of the bore of the OD of the rod to actually squeeze the bearing, and that's what then clamps the outer shell of the bearing and stops the rotation of the bearing. So I'm looking at the piston here. Let's look at the ring land and the pack of rings. Now I can already tell that the piston has got some hardened inserts for the ring land as well. So that makes it nice and strong. They're a decent amount down from the crown of the piston, but it would be nice to have a little bit more meat there, especially on the valve cutouts around here on both sides. So if the ring is actually slightly further down, it means that it's a little bit stronger. Between the top ring, compression ring, and the second ring, there's a decent amount of material as well. I'm just going to get my verniers and have a measure. So we've got about 4 mil between the top ring and the second oil scraper ring. So that's a decent amount of material. The weaker pistons normally have ring packs which are fairly close, and I can see that the control ring as well, the oil control ring, is definitely the newer kind of 3-piece ring, new technology. Yeah, they look like a great piston, almost like a slipper piston, because there's very narrow thrust surfaces on this engine, so there's not much friction and losses through the skirt of the piston. A more conventional piston will be a lot wider around the skirt, give it more stability. But yeah, they are definitely looking like a very modern piston. You can see from the casting and you can see from the forging that they're kind of quite oddly shaped. They're trying to put some strength in the piston as well. The pin bore is quite chunky, quite thick, but the rod looks a little bit weak at the top. If you look inside the rod, you can see it goes very narrow at the top. So yeah, they do that for some float and some more clearance around the crown, but it does make the rod fairly weak. But yeah, altogether from a stock engine, very well put together. Yeah, lots of time and effort gone into designing this engine for sure. Yeah. So let's take a look at the wrist pin. From a stock engine, I have never seen a wrist pin that thick before. It also looks like it's got a DLC coating on the outside, and this will help to aid friction or friction losses and any scuffing from the pin bore. Let me grab my micrometer and let's see what this measures up at. Now I've taken the pin out of the piston and split the rod. Looking at the thickness of the wrist pin, she's a chunky boy. She's a 24mm OD and she's got a 5.4mm wall thickness. I mean, that is pretty monstrous. So I can see this engine taking a lot of power in standard form. Again, inspected the pistons, they look amazing. So yeah, we'll break out the aftermarket pistons and we'll check the wrist pin thickness and we'll check the piston design, and we'll see where Toyota have improved on piston designs over the years, and find the weak links on the engine. So far I'm going to say the little end, from looking at rods over the years. Yeah, let's have a look at the little end. You see the little end, it's got that narrow passage there. I mean, that's quite thin there, so yeah, we can definitely have some improvements around this area, although the wall thickness is fairly large. So yeah, it's a decent thickness, but I'm just not too happy about that dimension there, especially if we're going to pull some big RPM and some big boost. So to show you something interesting, I have got two pistons now. I've got the original piston out of this 3-cylinder GR Yaris. I've also got a 2001 V8 Formula 1 piston. So in my right hand here, I have the GR Yaris piston, and as you can see, she's quite chunky, but yeah, very small skirt area. And in my left hand, I have a Formula 1 piston. You can see they are taking influences from, you know, Formula 1 engines with how short that slipper piston is. Obviously the crown and the deck height and the pin dimensions are all very different. But yeah, it just shows you that the technology is moving on with the pistons and their designs. There's lots less parasitic losses with this style piston, but it's not very stable in the cylinder. So that's why they need a little bit more, you know, meat around the areas to keep the piston stable whilst it's whizzing up and down the boards, you know, hundreds of times a second. So yeah, it was just interesting that I picked up the Formula 1 piston and I can see the resemblance between the two. So I'm going to use my initiative. I'm going to go work outside in. I'm going to hit all the 12mm bolts first and then I'm going to undo the mains. But I just want to make sure that the crank spins freely. So the crank does spin very freely. It's got just a normal weight oil in there at the moment, but there's no tight spots. It feels very smooth, you know, 360 degrees of its rotation. Yeah, it does feel really good, that. Anyway, let's crack on with undoing the bolts.
If only I could work this fast in real time. So here I am, just cracking off all the bolts, outside in, running them out with the buzz gun, putting them all in bags labelled where they come from.
So I'm going to use my experience now and I'm going to undo all these main caps. We've got 10 12mm bolts holding the outside of the cradle in, and I'm going to work from the outside in, work from the front of the engine. Let's see what these are done up to. Wow. Yeah, they're pretty tight. We're at about 130 to undo that. Oh yeah, they are tight. So the deformation of the cradle. So you've watched me undo the 10 12mm bolts around the outside, and I've just cracked off the main studs. They're pretty tight, about 130 Newton meters to get them undone. Now, the interesting thing, we've relaxed everything now, and the crank has gone rock solid. Can't turn it over. Come and have a look. So that shows you just how important it is to make sure that everything is all clamped down correctly when you're building the engine. Obviously disassembling is slightly different, but yeah, you can see that this block was machined and everything was torqued down, then it was bored, line honed, and then stripped, crank put in with its bearings and bolted back down again. But yeah, it's crazy to think that the engine can actually lock up when you're disassembling it. So now taking the cradle off of the engine, there's 2 access points. You do not want to be hammering and chisel or anything like that on any of the joint face surfaces. Let's quickly inspect the thrust washers. So we know somewhere in the cradle or the block there's going to be some thrust washers for our end float on the crankshaft, and I can see them. They're actually on number 3 main, just sitting down here. So let's pull the crank out and they're going to fall on the floor. There you go. That's the crankshaft of a GR Yaris. Fairly small. Could definitely do with, you know, EN40B fully steel crank. That would make a big difference. But we'll see how far the stock cranks can go. Just inspecting to make sure that the numbers are the same. 2EA, 2EA. So they are the same. So I'm going to pop the bearings and the shells out now, and I'm going to keep them in the same order. That's the 4 out the block. I'm going to take them out the tunnel.
Moving on to the crankshaft counterbalance in a minute. This is quite interesting. It's the only way you can do the crankshaft. You need to add material to it. So by drilling and tapping the crankshaft, you can insert
As you can
slug.
see, threaded into the crankshaft, so I can spin these in and then I'll weld over the top of them. And that's both webs. That one there. And that one there. There's no way these will ever come out once these are welded, and then we can just take material from this side or the back of it here or this web here to counterbalance.
End-to-end balancer this little gadget is. You need the tools to be able to do the job right, and this is the crank balancer. Very good bit of kit.
And there we have it, that's the crankshaft on the crank balancer with its counterweights. Now we're in like 0.19 of a gram, so getting really close now. Dave's just got to finish off the flywheel and then we come and pick it up, put it in the engine. Yo, so we're back and we're already put the crank in the GR Yaris engine. This engine moves so much, I can't explain how much it moves. So with my bore mic, it's moving nearly 8 thou. So the tunnel of the engine, untorqued, is 8 thou difference from when it is torqued. I mean, I've never ever seen an engine like this before. So it shows you that they are a little bit fragile. You do have to be very careful when you assemble them. I'm now doing all the ring gaps, but the crank's all in, spins beautiful. Yeah, now we're doing all the ring gaps and gonna fit the pistons and rods. Here are all my ring gaps. Here's the pistons and rods. It's a Nitto combination of rods and pistons. I was a little bit wary with the rings. We've got quite a large second ring gap and a fairly large top ring gap. I normally set them about 18 thou, 19 thou, and we're at 21 already. Can't do anything about that. That is straight out of the packet, and yeah, they're already too big. So what can I do? I can't do anything about it. The bore's been honed an extra 2 thou like it's meant to be done, so it gives us a 3.7 thou bore clearance, and the rings are slightly too big. But it's within tolerance. They say it's 5.5 thou per inch of bore. When we do that, it's about 19.5 thou, so it's just a tad over. The other thing we've been doing is we've been prepping everything. So over here, everything is all lovely and clean, all laid out, ready to be assembled onto the engine, which is great. It just means that I can screw it all together now. I'll carry on, maybe do a bit more time lapsing on it. But yeah, it's all going together really well, and then we can bring you along for the ride to make sure that you see the engine going in the car, and then on the dyno, and then all the power it does as well. And guys, keep watching. Check out the short block, it's all assembled. All its Nitto components in there, rods, pistons, crank balanced, all put back together again, aftermarket main studs. What an absolute crazy day today. I've been assembling the GI Yaris, I've done all the short block, then I've done the cylinder head. I made a few changes to the combustion chamber shape in the cylinder head, took some peaks off as well to make sure there's no hot spots in the combustion chamber, put this new HKS head gasket on, Kelford cams, dialed it all in, and it's looking sweet. We're just doing the turbo kit, intake manifold, injectors, fuel rail, fuel flex, and a few other bits as well, but it's looking really cool.
Got to have my tunes going, just keeping the energy levels up whilst we're building this one. Liking the red intake manifold, looks pretty cool. The exhaust manifold ain't bad either. Yeah, this is looking much nicer now. That's got the turbo on, very tricky to fit actually, not much space for anything. Looks much better now, this engine. Got a big honking turbo and a decent inlet manifold. Anyway, that's it from me, and I will see you on the next one.